We are going to continue solving applications involving quadratic equations. This time we're actually going to model a projectile motion, and most of those are parabolas. If you throw something, it normally has a little bit of an arc to it, and so we're going to use that, and we're going to look at this formula right here. It says if air resistance is neglected, the height, s, in feet, of an object projected directly upward from an initial height of s sub 0, so this is your initial height, with an initial velocity of v sub 0 feet per second, and acceleration due to gravity, which is a sub 0, is given by the following equation. So this is the equation that we usually put things into. T represents the number of seconds after the object is projected. So in other words, T can be 1, 2, 3 seconds, that type of thing. So let's look at our example. If a projectile is launched upward from the ground with an initial velocity of 73.5 meters per second, neglecting air resistance, that's pretty important, its height its height in meters above the ground, t, seconds after projection, is given by the following equation. S is equal to negative 4.9 t squared plus 73.5 t. So think about, here's the ground, and we're going to project something up, and then it's going to come back down, okay? Think about a fly ball or something of that nature. It goes up and then comes back down. That's what this is modeling, okay? The negative 4.9 is gravity working on it. That's what brings it back down. So after how many seconds will the projectile be 245 meters above the ground? So 245 meters is my S, my height that I'm looking for. So I'm going to have 245 is equal to a negative 4.9 t squared plus 73.5 t. I need to move everything to one side, so I can subtract the 245. That's not a problem. And I still have plus 73.5 t minus 245 now. 245, not, let's see here, that's a 9, 245. Okay, at this point, use the quadratic formula, use factoring, whichever you want to do. I don't like working with decimals unless I have to, so I'm actually going to divide all three of these by a negative 4.9. Have to do it to my 0 too, just to be consistent. So I'm going to divide all of these by a negative 4.9. What that does is it's going to give me still 0. Negative 4.9 divided by negative 4.9 gives me a positive t squared. Positive divided by negative gives me negative. 73.5 divided by 4.9 is actually 15. And then a negative 245 divided by a negative 4.9 is going to be a positive 50. Much easier to work with these numbers than it is these decimals. Again, you could do whichever you wanted to. I just prefer to work with these things. Now again, you can use the quadratic formula because remember it works on all of them. But I'm actually going to factor this one because two numbers that multiply to give me 50 and add to give me a negative 15 is going to be a negative 10 and a negative 5. And I can just put the numbers there since I have a leading coefficient of 1. My numbers just go in my positions. So now I actually have it factored. And so I'm going to set each one of these, t minus 10 is equal to 0, and t minus 5 is equal to 0. So I'm going to solve the first one by adding 10 to both sides. So I'm going to add 10 to both sides. And I get t is equal to a positive 10. Which, what does t represent? T represents the number of seconds after it's projected. So honestly, t, time, just like in length, has to be positive. So t equal 10 seconds is fine. Let's go ahead and solve the other one. I'm going to add 5 to both sides. And so t is going to equal a positive 5. Well, that fits in my limitations okay. So why are there two separate values of time that this is possible? Look at the path of this projectile. It goes up and then comes back down. So let's say that this right here represents 245 meters. Notice, there's 1, there's 2. So this would be like 5 seconds, and this is 10 seconds. So the ball, or the projectile, whatever you're looking at, is at 245 meters 2 separate times. Therefore, the projectile will be 245 meters above the ground after 5 seconds and again after 10 seconds. So there's actually, on this particular problem, there's 2 different times that the projectile will be 245 meters above the ground. Continuing with the same problem, so I'm going to rewrite the equation that we were given, which is s is equal to a negative 4.9 t squared plus 73.5 t. How long will it take for the projectile to return to the ground? So let's go back up to, or let's draw my picture again. We have the ground, and we send this object up in here and then down here. So this right here is at t equaling 0. Okay, it starts out at the ground and then shot up. So it's going to hit the ground again over here. Now if you think about the height where it hits the ground, the height is 0. So I have 0 is equal to 4.9 t squared plus 73.5 t. Now I'm just going to factor out whatever's common. I can use the quadratic formula, but I'm just going to factor out my greatest common factor. And even if I don't know my numbers, I can see that there's a t in both of them. So I can factor out just the t if I wanted to, giving myself negative 4.9 t plus 73.5 times a t. So then I'm going to say t is equal to 0, which makes sense because times 0, it's at the ground. And then negative 4.9 t plus 73.5 is equal to 0. I need to add this, or I'm sorry, subtract the 73.5 from both sides. And so that will give me a negative 4.9 t is equal to negative 73.5. I now need to divide both sides by a negative 4.9 so that those will cancel out, giving me t is equal to 15. Even if you use the quadratic formula, you should come up with 0 and 15. So the projectile will return to the ground after 15 seconds. Notice I didn't put this one in there because that's the start, and it's just asking us when it will return to the ground. So try some of these where you have modeled using quadratic formulas or quadratic equations, and then let me know if you need any help.